we are going to talk about a relatively new concept called structured concurrency. Before we dive into this, a word of caution. This is not production ready. This is a it's a pre-release, so you cannot put this, you shouldn't put this into production. Whatever I show you can and may change. Just that's a caveat, keep in mind. So essentially, by the way, let me step back for a minute. I want to rethink about this I want to say, both in life and programming, we solve a set of problems only to discover that we now have created a new set of problems. This is the life and programming we see this, because 30 years later, we are still talking about concurrency library, because we are discovering solutions, and then a few years later, we discover what really went wrong in it, and we come up with new solutions. And this is a hard problem to solve. And so what is the problem we are trying to address? Way back in time, we had threads. We kept creating threads that was not very effective. Then in Java 5, we have the executor service that was introduced. Executor service gives us pool of threads, and you can start scheduling things on the executor service and ask it to do the work for you. Well, that's great so far, but there are some issues we eventually run into. And that is, we can run the task in parallel using executor services. Let's take a look at an example, if you will. So I have a little mocked up example here. So I know this talk is about concurrency, but if you talk while I talk, we run into a race condition. So you demonstrated really well. Thank you. Can we now put a little synchronization block and you lock yourselves out until I finish the talk? Deal? Thank you. So essentially, we have a get name of airport, and I'm getting a IATA code, and I'm just marking this up. If it's Oz, return Austin, IAH return Houston, DFW return Dallas, SAT return San Antonio. So just a few airports around Texas. If it is none of them, throw an exception invalid airport code and return that code. So this is getting you the name of an airport given a code. So in the main, what I'm doing is I'm going to ask for names for Austin, Houston, DFW, and San Antonio. So I create an executor service. And in the executor service, I have a future. I iterate through the executor service for the for loop. I submit the task to it, and I say, get the name of the airport for that code, and I add it to the future, and now they will schedule those to run concurrently. Now, you could say, gosh, why would you need threads for it? That's why it's a mock. Imagine you go to a remote service to query for it. There is a third-party service on the web somewhere that when you send it IATA code, it will send back the name of the airport. So that way you can look for various airport code and names from around the world. So because it's going to take a delay to go get it, you are just firing them off in multiple threads, right? That's the idea. So then, in this case, once we have dispatched those calls, we are then saying, go back to each one of the futures and ask for the name of the airport. Shut down the executor service and wait for it to really terminate and then finish it. If anything failed, report it. So I run the code right now, and this is a little example. You got those names listed for those airports. Worked really great, isn't it? No problem. But suppose you had IAH and there's a task rather than a SAT. You have a TAS. Right in the middle of this, what's going to happen if you run the code now? So when you run the code, you had Austin and Houston, but notice invalid airport code, TAS. But wait a minute. What happened to Dallas and San Antonio? They were not processed. But the question is that what you want? Is that what you want when there's a failure in the middle? Would you want to abandon the rest of the calls, right? The answer is, depends on what the business wants. But if the business says, hey, you need to report failure for tasks, but you still need to get me the data for the other things, this is not doing it. Why? Thank you. So in a multi-threaded situation, you are not able to recover from this error and continue processing it. And actually, the unfortunate thing here is, if you understand the code, actually, to be realistic, what happened here was, this particular get is the one that blew out. And the other ones didn't have a problem. They are finishing it. But when you call the get, that blows out. And because it failed, you caught the exception way down here. Well, you could have said, wait a minute, let's try something a little different. What if I went down here and I put a try right there around that get, right? Around that get, and I'm going to then say a catch and whatever the exception you are receiving right there, and I'm going to get that exception, and I'm going to output the exception like so, and that's what I want to provide in here. So if you run this code, what does it say? It says, again, Austin and Houston. Let's actually make sure, let's say exception here, because that blew out from the middle, right? So let's go back and try this again and run the code. Yeah, notice that? That was Dallas and San Antonio, so they were continuing. But when this thread failed, it gave you that exception and brought it back to you. Okay, so it behaves in one certain way. So when the multiple threads are running, if one of the threads fails, thank goodness you're able to catch that exception, but the other things are still running. But let's step back for a minute and think about a problem we are trying to solve. While this is fine, if you had a hierarchy of tasks to perform, imagine these airport codes are all part of a bigger problem you're trying to solve. And in solving the bigger problem, you're saying, I need to have control over successes. I need to have control over the failures. And if things succeed, I want to get the results, work with them. If there was a failure, I want to get control and work with them. So the question is, how do you gain more control from this one? So this takes us to a special set of problems, which you can call as a parent-child relationship, if you will. I like to think about this as you have a problem which can be divided into smaller problems. And the solution to the bigger problem is arrived at by solving the smaller problems. We often may call it as a divide and conquer solution, though that's not a great terminology. So essentially the idea is you divide the bigger problem into smaller problems and you solve the smaller problems and then accumulate the result to bring the solution to the bigger problem, right? So that's a very common strategy in programming. So if you're going to do this divide and conquer kind of a solution, and you're going to solve the big problem by solving smaller problems, then there are some situations you need to be comfortable with. And where this takes you is that you have a parent. Now imagine this for a minute. Suppose you have a parent task, and the parent task divides your problem into 3 children tasks. So now the parent is waiting for the 3 children to finish. When the 3 children finish, the parent can take the response, put that together, and return to you. Great. But there are a few different possibilities now. All the three children succeed, that's one option. One of the children fail, that's another option. What do you do when a child fails? Do you still work with the remaining solutions? Or do you fail the entire operation because one of the child failed? What is the answer? Beautiful, it depends, right? It depends. But you cannot say it depends and walk away, because when they do tell you which one to use, you need to be able to provide a solution for it. If you are only using executor services, and if I choose one of those options, it's very difficult to implement it with executor service. Let's think about it. What will you do with an executor service? Suppose when one child fails, you want the parent to fail, but you want the children also to quit right away. In the executor services, there's a small problem here, right? So let's go back to executor services. In the executor services, I'm going to say, we come in here to compute, and I will say, if there was a problem, failed right away, just for our purpose, I'm going to say a try, and I'm going to say thread.sleep 1000, give it a little delay here, a catch, let's say exception, EX, and now, what should I do here? I'm going to say, if it succeeded, just for our purpose, I'm going to give you a 5 seconds delay, just so you can simulate it, right? And then I'm going to output done processing, and let's do the IATA code. So how does this feel like? Let's take a look. So if I go back here, I don't have the task right now. When I run the code this time, you will notice the delay of that 6 seconds happening. When the delay is done, you are noticing done processing each of those and the response. Great, isn't it? But if I add TAS and run the code, what's going to happen? In this case, you're still going through the delay right there. Why? Because you were waiting on the first one to finish. And the first one need to finish before you get the data. But that's more of the way we are getting the response. That's our problem, right? But did you notice something else? Every one of them finished, even though TAS failed. To make it more clear here, let's change this to TAS and then add AUS after that and run the code again. And this time, notice that failed right there. That's good. But what are you noticing? They all still are continuing. And if you said, hey, I don't care about the result after all, then in that case, I'm going to remove this try, and I'm going to remove this as well, and I'm going to simply say, go run this and get the data when you get it. And if I run that code, you can see that on that failure, it reported the failure, but guess what? It still is waiting for the other children to finish. What's the moral of the story? When one child fails, the other children still keep running. How do I tell the other children, one of the child failed, I no longer need you to run? Am I making sense?
Yeah.
Thank you. So if I have to tell the other threads, don't run, I have to notice this failure and put a little flag. I know some people, programmers, always find violent names for concepts. I don't know why. Divide and conquer, right? I won't even mention the other one that's very cruel. But we call this poison pill, right? You put a poison pill, and you set the poison pill, right? And what do the other threads do? As they're running, they keep checking the poison pill. And if the flag says exit, they exit. And they don't complete, right? But that is a lot of work for us. Besides, if that is a long-running task, you got to start writing code to break it in the middle. So you keep checking this, right? Because if it's in the middle of computation, it's not going to get interrupted. And if you're making an I/O, it will get interrupted. But if you are in the middle of I/O, and if it's a poison pill, there is nothing to interrupt it because you got to check the poison pill. So you got to start thinking, how do I make this work? And you say, I have an idea. I will not have the thread. I will have a thread that calls another thread, and this will keep checking the poison pill and then interrupt this. How do you feel about the solution? Not great, isn't it? Would you want to implement this solution? No. That's why you hire the interns, right? And then you tell the intern, here you go. While I have lunch, you can have fun with it, knock yourselves out. Not a very entertaining code to write, right? So what do? Now you understand what structured concurrency is. The word structured, I like to think of it as a parent-child. So it's very structured. So your parent starts children, and the children are under the supervision of the parent. When all the children succeed, the parent can succeed. The parent can say, I want all the children to succeed. A parent can say, I want only one child to succeed. What is that called? Parent with a bias. No. That is called optimization problem, right? That's called optimization problem. And why is it an optimization problem? Because any one of these solutions is an acceptable solution, right? So as a result, I have 5 children created. One of them discovered the answer. I don't need the others to run. One succeeded, I'm good. We can go. For example, imagine you have a bunch of people doing stuff in your work, and you want to find a solution, and you tell your team, hey, let's go look up the solution. And everyone in the room starts searching. Some use Google, some use Bing, some use ChatGPT, whatever, right? And everybody's like looking for answers. And one person says, I got it. What do you say to the rest of the people? Hey, we got it. Don't waste your time looking up more, right? If they are continuing to keep looking, that's a waste of time because solution for any one of them is good enough for you. So you want to save on resources. In this example, when it failed, the others didn't quit. So you could say as a parent, I want to win when all the children succeed. If any one child fails, I want all the children to quit because I no longer can use the solution because the solution to the problem requires all the subproblems to finish. So we are looking at 3 scenarios. So far, so good. How do we implement it? Just a small side note. Structured concurrency uses virtual threads. I spoke about virtual threads in a talk yesterday. You don't have to listen to my talk, but if you know virtual threads, that's great. If not, just make a note of it. Go look at virtual threads. But when you use structured concurrency, you are using virtual threads. Now, you are going to be able to interrupt things and gain from it. So let's understand how this is going to work. So I'm going to go back to this particular code you saw here, and I'm going to modify this code just slightly in this case. So what we are going to do here is, we have this list, and rather than going through this solution, let's just comment that out for a minute, and let's go back. Actually, you know what? Let's get rid of that for a minute. Let's work through this again. So the goal is to get all these solutions and work with it, right? So let's get rid of the tasks. Let's just work with the happy path for now. We'll come back to the unhappy path a little later. So let's go back here. Let's get rid of this right there. And what do we do here? So what we're going to do in here, let's put a catch, an exception, and report that. And we'll come back to that later. Okay, good. So the first thing I'm going to do here is a var, and I'm going to say, we'll call this one as scoped. So this is going to be a structured task scope. So we'll say scope is equal to a new structured task scope. And a structured task scope is going to return a string as a response from it. Now, the structured task scope is actually, in this case, the structured task scope need to be closed. So you use the try with resources for that reason. So you say try and structured task scope, and you bring it in. You look at this and there's a yellow squiggly. Let's understand what the yellow is saying, and we'll ignore the yellow squiggly after that. It says is a preview API and may be removed in the future release. Very encouraging for you to sit here. The people who left the room know this was coming, right? They're like, I'm out of here. So it may be removed in the future. So thank you for being here. No, I think it's going to stay. But that's a disclaimer they have to put because it's a preview release, right? This has been changing. I've been speaking about this for nearly 2 to 3 years. And almost every time I speak about it, it's a different code. So it's been evolving. That's why you cannot put this into production, right? So you have that string. And what are we going to do here? A var tasks equal to new array list of structured scope task. We want to really create these tasks. You know what? We'll get back to that in a few minutes. So let's start with that. And I'm going to simply say string so we can extract that out in a minute. We'll get to that. So then I say a var, in this case, IATA code that comes from, where it's coming from, IATA codes. So for each of the code, I say tasks.add. And what am I going to add here? Scope.fork. So you are asking it to fork. Fork is how a parent creates children, right? So I'm in the parent, and the parent says, I'm going to fork these 5 children, right? So it just goes and calls a fork. And what is a fork going to do? The fork says, I'm going to call get name of airport for the IATA code I have on my hand. So that basically is really providing a subtask, right? So this is subtask, that's what we are working with, of, in this case, a string. That's what we are working with. So that's a subtask of string. We put that into the tasks. Once we put that into the task, what are we going to do next? We are going to get the data from them, right? For each of those processes. So scope dot, and you can say, is shutdown, are you done? No more execution. You can ask it to shut down, join until, and you can block and wait for the processing to be over. So join until, and instance dot, and you can ask it to wait for a certain duration in time as well, and say, move forward when this time expires. Actually, let's come back to that later. So what I'm going to do then is to say for a task in tasks. And what do I want from a task? Task dot get. And I'm getting the data out of this. So I'm going to print it when I get the data out of it, right? So that's basically what we are saying. So I'm running the code. Remember, we introduced a 6 seconds delay on them. So they're running, they're done processing, and owner did not join after forking subtasks. Fair enough. So what am I going to say here? I'm going to say scope.join, and I'm going to call this. So we call the join function. So when I run the code now, what does it do for us is the question, right? So what does it do? So this case, it finished it and executed this and gave us the result. But before we go further, I did something wrong. I did something we shouldn't do when it comes to concurrent programming. Anybody knows what that is? Good try, but let me give you a clue. What I did wrong is on line 37. You're blocking it, yes, but anytime you do join of any kind, you're going to block. So the problem is not that I'm blocking, it's a little bit more than blocking. Blocking, what was that? This is easy to miss. Nope, no, blocking line 37. Bingo. This is a rule you need to keep in mind. So here is another lesson. Let's take this lesson. Both in life and programming, never do anything. Actually, you can stop right there. That's still a good principle, right? So never do anything without a timeout. That's a principle, right? Both in life and programming, never do. I have this philosophy, right? Never do anything without a timeout, especially young people. If you're looking for that perfect person, at some point you have to time out. Otherwise, you'll be very old and alone. That's not a wonderful life. So we got to be pragmatic sometimes in life as well. So time out and say, I'll time box this and see how it goes. Just kidding, but only partly. But the point really is that you want to call a time out. So don't use join. Because if you use join, you're going to wait forever, endlessly. And there's no way to know how long you're going to wait. I've seen this happen. People start something and they wait. And 30 minutes later, hey, it's not working. It's never going to finish. And how long do you wait for it? So if you put a timeout, at least you can say, oh, look, it didn't finish in that time, and I can do something about it. So we're going to change this, right? So scope dot join until instance or instant dot now. Okay, that's a little too brutal. This is being extremely impatient. Can you do it now? This code is written by project managers, right? Here's the problem. Are you done yet? So that's basically what it is. You know, you have children, right? And what do children do when you take them on a trip? Within 5 minutes after the block, are you done yet? Are you done yet? And those parents never tell the children, you're not done until you get to the destination. And the parents never teach the children. And the children then grow up and become program managers, right? I mean, I'm not kidding with you. When my children had a really hard time with me, I think. When my children were really young, we were going to go on a really like a 10-hour drive. So we get in the car, we start driving. We barely left the neighborhood, I think. And my kid in the back seat, are we there yet? Literally, are we there yet? And I pulled the car over to the side. I turned off the ignition. And I was just sitting. And he was looking around. And my wife knows I pull these kinds of stuff, so she's kind of quiet. And he's like, what happened? I said, we are there. And he looked the window and said, no, we're not. I said, we are there. No, we're not. So you know it, right? You know it. So next time you ask me, are we there yet? We will be there, wherever you ask me. He never asked me ever in his life again. So create good project managers. That starts when they are 5 years old. So pull them on the side and teach them the lesson, right? And don't ever ask my son how he feels about it. So the point really is, you call the instance dot now dot plus. Hey, they have not given weeks or years here. Okay, so I'll give it 10 seconds. How about that? So here's a 10-second to add. So let's go run the code. Let's see what it does. So here it goes. It's taking a 6-second delay, right? So it's not too bad. Let's wait for it. And there it is. So go back to what we saw a minute ago, right? So that is the structured scope, task scope. This is the simplest form, folks. You simply call the structure, you create the children, you wait for the mom to finish, dad to finish, and then you say, thank you, let me go get the data. So this is where a very basic situation of a parent-child relationship, right? That's what you're doing. For those who are very, very, very curious-minded, let's go back here, if you don't mind, and let's say output thread.current thread, just because we are curious, and let's output that. Notice they're all virtual threads. That's what I was saying earlier, right? So it's built on top of virtual threads. That's basically what it is. Got it. So let's go back to this. So now that we are here, one scenario is, this is a situation where you want to shut down on failure. You're saying, I've got a parent-child relationship. I want to get the solutions, but I want solution only if all my children succeed. If any one of my child fails, I want to immediately shut down the whole thing. Before we work on it, just to illustrate this, we added something, so let's take a look at it just to get a feel for it. So if you notice in here, we notice that you are reporting done processing, done processing, done processing. We got all those things in there, right? So done processing. So keep that in mind. Now, back here, we are calling the get name of airport. I wanted to check something here. We got a sleep here, and in this exception, we got to be careful with these things. So I'm going to say in here, throw new runtime exception EX. And I'm going to similarly, this is 5 seconds, I'm going to blow it out as well. Because if you catch and suppress the exception, that's not going to help. Got it. So let's go back to the code. And what am I going to do now? I'm going to say this is the structured task scope dot shutdown on failure. So you're calling shutdown on failure. So that's an inner class that you're calling. And the shutdown on failure says, if any child fails, shut down all the children and report a failure to me, right? That's what we are saying. We'll take it in baby steps and see how this works. So at this moment, no child should fail, correct? So we run the code because we got all the good data in this case. So we run the code, there goes the 6-second delay, and we finished it, and we got the responses, no surprise there. But if I change it to tasks right there in the middle, so run the code, what's going to happen? Did you notice result is unavailable or subtask did not complete successfully? Not only that, did you notice the other ones did not report completing? The other children were terminated as well because they did not wait to tell you, hey, Dallas is done, hey, Houston is done. They were terminated. You're like, I want to see it. I want to know it got terminated. Sure. Let's go back here and let's actually remove this for a second. And let's go here and let's output and run the code. Yeah? Notice those interrupted exceptions. That is the mom, the parent, sending signals to all the children. Quit, 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 quit. Because one of the child failed. So that's your interrupted exception that you're seeing right there. Got it? So that is shutdown on failure. Shutdown on success. What does that mean, shutdown on success? I want to succeed even if one child succeeds. I don't have to wait for all the children to finish. Just to entertain this thought, let's go back here and let's say in here we have a little sleep and we would say if IATA is equal to, let's say IAH. IAH. By the way, these airport codes have a special meaning, you know that, right? I fly a lot, and it took me a while to figure this out. But they were very smart in designing these code numbers. I would fly through Dulles Airport in Washington, D.C., and then I realized why they call it IAD, because I am delayed. That's why they called it IAD. I used to live in Houston. I am here, right, to say I'm home. So that's why they call it. Chicago is the worst. ORD, it's ordeal. Just struggle to get through it. So that's what I kind of get excited about, right? Airports have a meaning in their code. So that's IAH. So in this case, if it's Houston, if it is not equal to Houston, then I'm going to provide the delay, right? Not otherwise. But if it is Houston, we'll say else, I'm going to just give a small delay. So that way it's a little bit more interesting to watch this. So we'll give a 1 second delay, right? So what's going to happen now is the question. So let's go back to this code and try working with this. Did I miss out? Yeah, I'm seeing where that is missing actually. One more. Okay, so let's see if that's actually happy. All right, let's see if it is. There we go. I think it's fine now, I think. We'll find out. So I'm going to run that. This is still has one failure in it, right? So this is saying I'm interrupting it. That's on failure. But I'm going to change it to shutdown on. So success. So what does shutdown on success say? Shutdown on success says, if any one of them finish, you can shut it down. But in this case, we're going to make some changes to the code in a minute. So we run through it. Did you notice? Done processing IAH. But notice the interrupt on these. Why? Because the parent says, hey, this child succeeded. Right? Interrupt the other ones. I don't need you to run anymore because I got what I wanted. So this is the example I said. We want people to search. You found one search. You can terminate the other searches. Look how mindful you're on resources at this point, right? So they're saying, don't keep working on the operation. Bring it back in. No need to waste your time on that. So that is basically what this is doing. Now, of course, when you come back here, a result is unavailable. So obviously, that's not what you want to get. Let's see how we're going to fix it. But before I fix it, I want to go back to the shutdown on failure for a minute because we want to be able to handle this in a better way. So let's go back to the shutdown on failure. So in this case, on shutdown on failure, you're saying go ahead and run that. But you're going to shut it down if there is a failure, right? So what are we going to do? Scope dot, and you can say exception. And the exception will give you the error if there was a failure. Now remember, it may actually succeed. If it succeeds, you won't have an exception. So as a result, the return is an optional because you may or may not have an exception, right? So that is something you can do, is to receive that exception, if there was one. So I'm going to go back here, and I'm going to output, in this case, this is going to be the scope dot exception. So I'm asking it to report this exception back to me, and I'm calling it, right? So if I run this code, you're going to see optional invalid airport code TAS. So it gave you that exception because it's a shutdown on failure. You say, no. I don't want to get the exception. If there was an exception, if there was no exception, I want to continue processing. If there was an exception, I want to terminate this. So scope dot throw if failed. So you're saying if that failed, then here, take that exception and throw that exception to the caller of my code. So as a result, the rest of the code after that will not be running. So notice in this case, it's saying runtime invalid airport TAS, and that's an exception that was thrown. That's called the execution exception. So you can call methods like throw if failed, and you can specify that as well. So you can catch the exception, you can receive it, you can rethrow it, you can do those things. Alternatively, if you are dealing with the success. So let's think about this for a minute. If you only used this, the structured task scope alone, what does that mean? You got multiple children running. When they all finish, you want data from each one of them. And then you can collect them and do whatever you want to do with it, right? But here, you said shutdown on success. Maybe the name is a little misleading. Maybe the name should say shutdown on one success or any success. That's what you're really saying, right? Not on success as to everything succeeded. So shutdown on any success. But if you're shutting down on any success, how many results are you going to get? One. At most one, right? At most one. You don't care about multiple results because the minute one succeeded, you're going to get it, right? So that's why if you're using shutdown on success, it doesn't make sense to do this, right? Because you're saying, let me check with every child what the result is. And you're like, no, you're going to get one. Don't query the other children. So what's going to happen now if you run this code? When you run this code, right there, Dallas IAH finished. Those others were interrupted. Result is unavailable or subtask did not complete successfully, which is misleading. But why? Because it's from this. You're asking the question that you're not supposed to ask. So what am I going to do? Let's comment that out. But I want the result. I haven't gotten the result yet, right? Now I'm not getting any result. Notice we're not telling what the city is. So how do I fix it is the question, right? So what we can do is scope dot, and in this case, I can call the result. Scope dot result. So what does scope dot result do? That one successful result you're going to get. So run the code, and there is Houston right there. And you by calling the result function. So the result function says that one child that succeeded, I'll take that result and I'll give it to you. If no child succeeded, then you're going to have an exception. And if you call the result, you're going to get an exception because no child succeeded. And that's basically what this provides for you. So you have a fork and you have a join. So essentially, it's for a hierarchical solution. So where would you use it? you're taking a problem, you're chopping the problem into child problems, and you're running each of the children, and the children are executing under the supervision of the parent. And when a child were to fail, the failure is propagated to the parent. And the parent can now propagate the failure to the children. And so as a result, if you draw a circle around the whole thing, they're all part of one family. And as a result, you're able to manage this hierarchy of tasks. That's why it's a task, structured task scope. And so as a result, if you have a problem where you have to explore directories on your system, you're given a top-level directory, you go query the child subdirectories, and you can create a scoped task, give one child directory to one child fork. So they are processing the child directories. And if they finish, they can report to the parent. Now you say, but when my child is starting, my child may have other subdirectories. You can make a decision. Should they be children and parent, right? At some point, the child becomes the parent, right? That could be a possibility. Or you could have the, thank you, you could have the grandchild report back to the grandparent, which is fine too, right? And then you don't have to keep creating more structured scope. You can pass the structured scope to the child, and the child can create children using the parent scope. So the children are not the children of the child, but the children of the grandparent. Like, again, that's like supervision, right? And that happens in a lot of families, right? You are a child, but you're under the care of grandparent, not the parent, because the parents are way too busy running around. So that is possible too. And so it's up to you how you design. But how do you decide? You decide based on what that's the reason why it's a scope. What's your scope? Are you running under the parent scope? Or are you running under a sub-scope of the child? You can decide the scope. So we saw why it is structured. We saw why it's a task and why it's a scope. Nicely chosen words, right? That's why they call it structured task scope. Every one of those words have a meaning in it. And that comes through. And that's the fork and the join that you have access to. So we saw the fork. We saw join versus join until. I really wish we didn't have a join, honestly. Yep. No, right? Why? Because if you call join, you're going to wait for a long time. Potentially you have a live lock, something that would never complete, and you're waiting endlessly for it. So one of the rules to follow is never call a blocking function without a timeout, right? Always use a timeout. We also saw throw if failed. So this is on the one with the failure. If there's a failure, you want to propagate the failure up the chain, you can call throw if failed. And we saw how to collect the results of the execution. We saw how to deal with the exception as well. So that is the story of structured concurrency. There is one more small detail. And I would argue maybe that's not really part of structured concurrency. And that is a newer concept called scoped variables. I'll just mention a few things about scoped value. So what's a scoped value? If you have multiple threads, and if you want to pass information across these threads, it becomes really hard to pass it. But there is one problem you often deal with in programming, and that is you are at a level and you create a subtask. The subtask is running, or you call a function which calls another function, but in turn, they may turn around and call a function on your own layer. This typically happens when one function calls another function, but sends as an argument a lambda that belongs to a call to function on your side. So here is a way to think about it, to understand what this means. So in this case, suppose you have your code and you have a function f1, but you have a function f2. This says lib.call f1, and it passes the function f1, like a method reference, if you will. But here is the lib code, right? So the lib code, what does that have? The lib code has a function, a call, which takes a function. Let's say this is a integer, comma, integer, right? Doesn't matter. What does this do? It turns around in this call and calls f with some value, right from this call function, right from here. So the idea behind this is you're on that side of this. So right there is the function you're calling, right? And you're saying, I want to call the function f. But what is f? F is f1. But in this case, you have a small problem. f2 wants to send some data to f1. Let's think about this for a minute, right? Think about this for a minute. Let's say you call him, but you give a reference to the gentleman behind you. Well, you call, he calls back, but you want him to have a certain data. But how do you pass the data to him if you're making a call through another function? Well, you could do this. You could go to call and say, call, I've got an idea for you. Why don't you take an extra parameter? We will call this extra parameter as stuff. So you can pass stuff here as an argument addition to 4. In which case, this can take a stuff that is coming in and a value that you want to send to it. But guess what happens now? This call will have to know that your function wants stuff. If this is not going to call the function, but if this is going to pass your function to another function, what's going to happen? Every function needs to have an extra parameter. 2 weeks goes by, you say, I want to send 2 parameters. What is he going to say? He says, take a hike. I'm not going to do that, right? Will you say that? Yeah, take a hike. So when somebody says take a hike, what do? Can you do this for me? Right? So you can bribe them within legal limits, right? But that's not going to cut. He will take the money and say, take a hike. That's not going to help, right? So what do? So in this scenario, you don't have the ability to keep hacking this parameter. That kind of smells, right? So for that, what you do is the following. Get rid of the stuff from here, from both sides, remove that, and this is only taking a value, right? That's a value that's being passed in, which the caller wants to send to you, so that's good. But then, okay, not this one also, right? There's no stuff here. There we go. So what you're going to do is, let's only focus on this part right here, this guy right here, right? Up to here. So F2 says, I will create a scoped value with stuff. So it creates what's called a scoped value. By the way, scoped value is also not ready yet. So don't commit to it in your code. So scoped value with the stuff. Then it says lib.call. And it calls the function f1. But within f1, right now, in this case, you can say, get stuff from scoped value. So, in a way, a scoped value kind of gives a scope for a value. So all your code is running under that umbrella of a scope. So it's not global, but it's locally global, right? So you reach into your scope like the clock over there. That's a clock in our scope. I can look at the time, you can look at the time. I can change the time, and you will notice the change that has been made, right? But people outside the room cannot see it. So the idea is this is a global within a scope or visible within a scope. So this gives a nice way for you to call methods and surface back. So you send this code here, the call comes back here, but these two can agree upon a data they want to share. Rule number 1, it's a scoped value, not a scoped variable. What does that give you a clue? Thank you. It's immutable. So what you create in the scope value is immutable. Why? Because if anybody starts keep changing them, it becomes hard to reason about the code. It becomes hard to understand. So you're not allowed to change them. They're required to be immutable. That's another concept that's evolving right now. But you saw here how we can make use of structured concurrency. You saw here how you can build a parent-child relationship. And you saw how you can work with all things succeeding, one failing, or one succeeding, like for an optimization problem. And understanding all of this, you can leave with the power knowing none of this may even exist. So thank you for coming.